This is Advent of Code 2020, Day 7, Handy Haversacks. So we're at our layover, I guess, for our flight, and there's been some issues with the luggage processing. And so they need our help. We've got to figure out basically if our bag, which is a shiny gold bag, is going to make it on to the next flight, because we're definitely going to want that at our destination. So all of the bags have this color coding system. And so we're given a bunch of rules about what kinds of bags can fit inside of other bags. That's our input for this puzzle. And we need to figure out, based on those color coding bag nesting rules, how many bags our shiny gold bag could end up in. At least that's my sort of best attempt at summarizing this problem. So, yeah, let's just look at a quick example. So based on the above rules, a bright white bag can directly hold a shiny gold bag, same with muted yellow. We see that right here. But there's also sort of levels of nesting that can come into effect. So a light red bag can have a bright white or a muted yellow, and either of those will contain shiny gold. As another example, dark olive contain faded blue or black, dotted black. Both of those contain no other bags. So dark olive, for instance, would be one that can't contain shiny gold, and same with both of these. So based on this rule set, we would kind of be able to compute that 4 of the color-coded bags could contain the shiny gold bag. Shiny gold bag is not included, though, because it can't contain itself. And I think that's a rule that'll hold even for our large puzzle input, though we should probably double-check that assumption. So for the above input, we're trying to find 4. Similarly, for the puzzle input, we're going to see how many of these bags can eventually contain at least one shiny gold bag. There are a lot of rules. The list is quite long. That's good to know. Another assumption I'm making is that all of these numbers are going to be positive, greater than 0. I don't think we're ever going to have it say shiny gold bag 0 that it can contain. I think that's just assumed if it doesn't list it. And the reason I think that's important is because we're going to have to sort of parse apart this list where we're associating like a base bag here with what can nest inside of it here and here. And we're going to have to like extract that out for each line. Yeah. So before we look at the puzzle input, I kind of just want to talk about how I'm thinking about this problem. So drew up a little diagram here. And what I think we can do is have like some sort of like tree traversal kind of program. So if it were to say want to target the purple bag, just assuming there's a purple bag, then we would go and look and we'd say, well, let's look at the turquoise bag. That can't contain anything. So that would be kind of a dead path, but we'd traverse it till the end and find that out. Well, then we say, well, are there any other bags this can hold? Yes, it can hold this kind of magenta color. So then we go up here, and that can contain both the orangish, but then our gold. So we would say, yes, this purple can contain the gold. And so I think we would do that for all of these, excluding the gold one itself. And yeah, that at least at a high level is how I think we would approach it. Yeah, so let's see if we can get a solution going with this small problem set. And then see if we can get to 4, and then we can move towards something. Yeah, then we can move towards a solution with the large puzzle input. So Yeah, for starters, let's jump over here. Jump into an 07 directory and we'll say like our sample.txt, and we'll put this in here and we'll save that. I mean, I think we have to deal with parsing this, but I wonder if there's any like pre-work we can do to sort of simplify the parsing that has to happen. Like I kind of want to remove every instance of bags and bag, and then I want to like replace contain with like a colon because it's like the thing on the left is associated with the things on the right. Yeah, so just to type out what I'm thinking, like if, it'd be nice if I could turn this first line into, you know, something like light red, bright white, muted yellow. I think even if we were there, that would be just drastically simpler for our like solution code to deal with. Yeah, so we want to get rid of bags, clear contain. Okay. Let's save this, and perhaps for starters, reach for a sed command like this. This is something, kind of a pattern I've been using in some of the past solutions to clean up the incoming input. So I don't think we need to deal with new lines here. But we did want to replace instances of bag, and bags with just nothing. Maybe let's start with there and just even see what that looks like. Didn't like that. I wonder if I am doing this syntax wrong. Still no. Let's try this then. Okay, that gets rid of it. So how do I do? Maybe I have to escape these. Something I'm missing about this sed regex. Optional match. Oh, so they use parentheses. Oh. This is a part of extended regular expressions. Let's see what this is saying. Oh. So they're saying 0 one time. That's kind of clever. Okay, let's try that then. This would be tough to remember. I'll just copy that. It did not like that. Huh. Wonder what I'm missing here. Test. P. Is the P important? Wonder what that is. Said P argument. P modifier. Oh, come on. Oh, that's to print the line when you make a substitution. Oh, I don't want that. Well, maybe I should just take what I can get. Bags. There, that contain, that's pretty good. Then maybe we deal with this no other bags. We want that to say something like, yeah, what do we want that to say? Just like none or nil or null or... Yeah, let's say none. That'll be fine. So, no other bags. We'll deal with the period later. None. But another one where we replace these numbers, I guess. So if we find any number of digits and then a space, we just replace it with nothing. Not quite. /D, what did that do? Plus doesn't like that. Digit. Yeah, so look at this, the sed docs, and it's not telling us a whole lot. Kind of thought that would have been a better option than here. Yeah, maybe we just got to do this construction. Zero through 9. That's still not doing it. 8 through C. Yeah, maybe it's the plus. There's a plus there. Interesting. -R. Well, it looks like we don't support the -R. Just give it a little bit of a range to work with. 1 to 4 digits. That might work. And then add another one to remove bags, comma, followed by just a comma. Or maybe just bags. And then we need to get rid of bag 2. And then get rid of our dots as well. Place dots with nothing. Because you gotta escape the dot. Okay. So this is something we can work with. Should we take a look at the puzzle input now? Holy smokes. Oh, someone on one of the other videos told me, what is it? Shift A? Control A? Command A? There we go. Command A highlights everything. Thanks for that pro tip. Now we will add this to our input.txt. .594 lines. Actually, yeah, let's find shiny gold. Let's find shiny gold. It's at the start of a line. Good, there's only one. Okay. Yeah, this is looking good. They're all, as far as I can tell, 2-letter names. Striped chartreuse. Wow. Cool. So let's save that. Let's revisit our set command. Call it input, and we will jump to the end of the line here and output that into claim input. So now that I've pre-parsed this input, I want to see if I can sort of load it up in my implementation, parse it the rest of the way, and work towards a solution. I'll grab at least a line of this, and then say par1.ruby. Just put that there. And Yeah, so the way we want to, well, if we read in the whole file, I think we can grab a little snippet on how to do that. Oh, that's an image. That's brutal. Okay. File.open. Oh, we've got an iterable. Okay. Map line, and then for each line we're going to say line.split to break apart the sort of the source and then the destination bags, and then from there we will I think yeah, what do we have here? I guess we can take the source and unparsed dest. And then for each of those we can say, well, the source as is, but the unparsed dest we will split on the comma separation like that. Cool. And then we'll just, I guess, return source and dests. And we'll just call these, yeah, parse lines, something like that. And then I think we want to just map over these to turn them into some sort of hash that contains things like vibrant purple and then points it to yeah, like a list of shiny lavender, muted gray, muted bronze, you know, like that. And then that gives us sort of a hash that we can traverse through like a tree. So to do that, we will say parsed lines dot, yeah, we're going from an array to a hash, so we're going to need to do a reduce. I never remember the order of the accumulator and the, yikes, those examples aren't helping. I never remember the order of the accumulator and the incoming item. Okay, accumulator first. Great. I know that inject is the more, you know, idiomatic one in Ruby, but I prefer the word reduce, so that's where we are. Accumulator, and what do I have to give it this argument to? Probably accumulator, yeah, and line. And so for each of those, we're going to say the accumulator gets, let's pull out source and this from the line. I'll say accumulator source gets, yeah, I guess just this array of tests. You could almost just call toHash on this, but I think we need a special case the instances where we have, you know, spotted black pointing to, you know, none. We don't want that. We just, we want it to just be like nil, I guess, so that we know it's like a terminating position. It could just be an empty array, maybe. Either way, we're going to special case that. So if des equals none, then cum source gets this, else it gets this, and then we return the accumulator. And this is going to be sort of our traversal hash. And so then with our traversal hash, we can, I guess, initial states are keys. Let's get those keys, and then for each of our initial states, we're just going to find out if there's a way from that initial bag. Yeah, maybe we'll call them initial bags. Stick with the theme. So we can see if there's a way to get from an initial bag to the shiny gold bag. So we'll map. Let's call it bag, I guess. And we'll call, I don't know, we're gonna need some method called like traverse bags. And we'll give it, yeah, an initial bag and our traversal hash. Current bag, traversal hash. So with that, we can say, I guess if current bag equals shiny gold, then we return true. Like, we can stop traversing. We found what we're looking for. Otherwise, we can say traversal hash current bag. So basically look up the destinations for this current bag. What are the bags that can fit inside of it? And then for each of those, any, I think. Destination bag, we're going to say traversal bags, traverse bags. We're going to say traverse bags for the new destination bag, for the new source bag, which is one of our destinations, and the traversal hash. And so that's going to return, yeah, a true or a false, or it's eventually going to hit this any with a empty array, and it's going to bottom out. Because I think if you say .any It's just false. Cool. So we're going to call this for every single one. We're going to turn a bunch of trues and falses. And then we're going to reduce that to yeah, I guess we're going to reduce that to summit, filter, yeah, maybe we can just do that. Let's see if we get a solution there. Any, undefined any for no class. So what are we calling? How would this ever be nil? That makes me think we defined something, that something got parsed wrong. Yeah, let's pry in here and see what's going on. Oh, so we got a bunch of new lines. Ugh. Okay. Line.trim. Undefined method trim. Strip. That's what I'm looking for. I guess trim is a JavaScript. Undefined method truthy. That might be a active supportism. Whatever, I was just getting impatient. Filter. True can't be coerced into integer. What line was that? 40? Plus true can't be coerced into integer, type error, line 40. Size, that's some. 120. Let's see if we've got an answer to day 7. That answer's too high. Okay. So oh, you can't convert a... Oh, this was probably fine as it was. Filter into the truthy values. So then yeah, are we missing something? I guess we could skip some like recursion if we said return true if traversal hash current bag dot include shiny gold. It's still 120. Oh, I think I know what happened. I think the answer is 119 because I think we're erroneously counting the gold bag line, which a gold bag can't go inside of itself. So we'll say turn false if bag equals shiny bag, shiny gold. Yikes. Oh no. Didn't even print out a value that time. How could that be? Return false if bag equals shiny gold. Yeah, that's fine. I gotta think we just got some sort of formatting error here, such as using a return statement. 120. No, that should be fine. Return false. Bag equals that. Otherwise, traverse bags. Uh-oh. I just realized I'm using a bunch of camel case instead of snake case. I feel like Vim is struggling here. I'm going to quit out of this. Open it back up. It's just not printing out an answer. Initial bags, traversal keys. I'm really in a JavaScript mood today because I'm doing everything. In camel case. Bag results. Yeah, that's interesting that this is coming out with nothing. Map is initial bags map. If the bag's shiny gold, just return false. Why doesn't that work? One. So checking to see if the current bag equals shiny gold is shiny gold not what I'm looking for? Ruby. Yeah, I mean, I'm using this correctly, right? What's going on with this code? If the bag Apparently you can't call return inside of a block. I should probably know that, but it's too high. It's one too high. There we go. We got our gold star. Now without some struggle. Thanks for watching.